Well, good question. You see, this oscilloscope should actually have two probes, one and two channels. However, this oscilloscope is missing the analog to digital converter for the channel one. It's also missing the entire channel one hybrid unit, so channel one is completely inoperable for this oscilloscope. Channel 2, however, does have its hybrid, but it's missing the probes for it. It had no probes. These probes are actually supposed to be integrated right into the scope. There's no BNC connector like those. There's no BNC connector. It's just integrated exactly into the probes. I'll show you what it looks like. Okay, so here's the scope disassembled and open. You can see the front connectors, the CRT. And then here is the little probe thingy. This is a probe. Well, it's supposed to be the BNC end of a oscilloscope probe, specifically a Handtech one, model PP150. It's supposed to have some compensation stuff in there, but I just put a jumper inside of there. Can you see the copper wire? It just connects this to the coax here. I'll add a little compensation circuit into here to even out its frequency response, but I need my parts from DigiKey to arrive from that. But anyway, this is the acquisition board, or the magic of this oscilloscope. This is where it turns the analog to the digital. Down in here is where the probe connects to here. It's a little bit it was okay. Basically, the probes are supposed to connect into these holes, and there's supposed to be a little hybrid underneath them. It was missing this. It was missing the probes when this oscilloscope came, so I had to make my own little connection. I used a little bit of hot glue to secure the wire in place over there, and then used just regular pin headers or pin jacks, whatever you want to call them, pin sockets, to connect them up there. Alright, taking the oscilloscope out. Now the thing comes out as pretty much an entire block sandwich of boards. In here we have the other stuff, just interface board, user interface boards. Oh, and also of course the rotor encoders and stuff. There's the little tube, AD as can be. And now I'll proceed to removing this part right here. Alright, here's the ADC board open now, analog digital converter board. You see a lot of high-speed stuff. These interesting ferrites, which I assume is probably the delay line for something. I'm not exactly too sure what it is. Maybe impedance matching. This is the socket for the channel 1 hybrid. As you can see, it's missing this thing. So channel 1 is not gonna work anytime soon unless I get another one of these hybrids, which are quite rare, which is why I think that this one was left here. This one was left here because that thing was broken. So I think the previous owner used this as a parts unit to steal its channel 1 hybrid, which was presumably still good, and used it in maybe perhaps another 222. But they left this one, which is enough for me. I was able to just solder a little bit of stuff there. So now I can just use, where is it? This thing. I can just use this thing. It's not perfect, but as you saw, it's getting a signal through. If I were to input a square wave into this thing though, it's not going to work great. First of all, the voltage is not going to be correct because the input impedance for this thing is actually 333k ohms. So you need a 666k ohm resistor inside of this thing in series to get the 1 mega ohm impedance. It's basically a 1 to 3 voltage divider, and that's how this thing is able to achieve such high voltage ratings. So I can't just input a signal in there directly. And also, this cable is not exactly impedance matched perfectly for this thing. And so because of that, this thing is not gonna, if you input a square wave into here, it's not gonna have a flat frequency response. It's gonna have a little bit of distortion and curves. I think this is in terms of oscilloscope compensation, this entire system is actually undercompensated. So I'll need to work on that. But my parts from DigiKey should arrive. I actually do, or rather I should have the board around here somewhere. I don't think I do. Well, it's just, oh, there it is. Found it. Hold one moment. All right, so basically, this is our little compensation board. It has a little capacitor, a trimmer capacitor in series. And then in parallel with this trimmer capacitor should be a 1.2 mega ohm resistor and a 1.5 mega ohm resistor to get very close to 666k ohms. Now this thing will go in series by going in here like this when it slides under there, and then the B and C will be connected to this side, and the coax will be connected to this side. Doing this will make it, better. It'll hopefully help it have a more flat frequency response. And then I can just use a little adapter here to turn the male into a female. And then this way I can use regular oscilloscope probes, like my, let's see. Okay, well, it's kind of in parts right now, but I can use something like a P6109, the same type that my 2230 uses. Maybe I can even use that scope probe, but that one has a special impedance thing. It only goes up to 15 picofarads, I think, to compensate, so it might not be as ideal. But if I were to just hook that up and hook this up and hook that up, and it should be all good. Anyway, I had to take this apart anyway because there's some cold solder joints in here. The display changes sizes with percussive maintenance, so that's not exactly ideal. Also, the DC barrel jack here is not ideal either. It probably has some cold solder joints that I need to fix. And yeah, I really like this oscilloscope. It's really neat. It's compact. I'm actually going to use it for something useful and not just have it as a collector's item as most people do. And maybe I'll share with you guys one day what I'm going to use this oscilloscope for, but right now it's a little bit secret, a little bit of sensitive information for now. Maybe in the summertime, or maybe after summer, I can share with you what it is. What I was using it for, I should say. But yeah, that's pretty much all there is to it. It's pretty neat. I can show you more of the boards if you want more detail. You can see here, nice detail. What is that? Is that a common mode choke or a transformer? Probably a transformer. There's the CRT. There's this board here is the main processing board, I think. That's where all the brains are. And here are in this sideways board is just a CRT driver, I think. And this bottom one is also, I think, part of the CRT driven thingy. Or maybe, okay, down there is also processing because it's connected to the ADC unit. And yeah, that's pretty much all there is. There's another picture for you, or view, I should say. Another one. I need to fix these. These are not in awesome condition. And here is detail for this. As each has a little button. Yeah, it's really neat. All right, see ya.